Hello, honors geometry students, and welcome to Unit 6. Our first target today is we are going to introduce transformations, and transformations is really going to be the focus of this entire unit. Again, today's just kind of a brief introduction to the different types of transformations that we have and kind of how to identify them. So what probably a really good idea right now is just go ahead and pause the video and kind of fill in all these vocab words. There's a lot of information here right at the start. So again, go ahead and pause, fill everything in here, just kind of write down all these definitions, and then we'll pick it up in a minute and I'll kind of talk about what each one of these things are. All right, so our first vocab word we have is transformation. A transformation, again, is we're just changing the location or size of a figure. So we're going to manipulate this figure. We're going to change where it is. We're going to move it up, down, left, right. We're going to rotate it. We're going to flip it across an axis. We're going to, enlarge it. We're going to make it smaller. Again, we are transforming this figure. We're going to, if it's a triangle, it's going to stay a triangle, but it might be in a new location, or we might make it bigger, or we might make it smaller. Again, there are different types of transformations we can do, and we're going to explore all those. All right, so our next vocab word, this is a really important one. We're going to use this word a lot this unit, and that is the idea of what's called an image, okay? So the image is basically going to be the copy, all right? It's the new figure that is produced after a transformation. So if I have a triangle that I start with, and this is called the pre-image, which is our next vocab word. The original is going to be that pre-image. And then, one of the things we do is a rotation. So I might rotate something 90 degrees. And so again, the image is going to be the new figure that happens after I've performed that rotation. Pre-image is my original. The image is going to be kind of what happens after I perform my transformation. We're also going to use something called prime notation, which I'll talk about in a minute as well. All right, so the first few types of transformations we're going to do are called isometries. Isometries are also what we call congruent transformations or a rigid motion, okay? So congruence transformation is any sort of transformation that basically preserves congruency, meaning pre-image and image are going to be congruent to each other. All right, so I'll go ahead and I'll start a transformation. And again, if the pre-image and the image are congruent, meaning all of their sides and all their angle measures are congruent to each other, then this is an example we call an isometry. And three of the transformations we do are isometries, and that's going to be a translation, a rotation, and a reflection. The last one we're going to do is going to be a dilation, and a dilation is the only one of these that's not an isometry, meaning that the pre-image and image are not going to be congruent to each other, and that's because we're going to shrink or enlarge a figure. We're going to make it bigger, we're going to make it smaller. And instead of having congruent pre-image and image, we're actually going to end up with similar figures for this one. So similarity, where the angles are all going to be the same between my two figures, just one of the sides will be either bigger or smaller in my pre-image versus my image. All right, so like I said, there are 4 types of transformations, and we're going to go through all 4 of them right now. So the first one I have is what's called a translation, not to be confused with transformation. All right, a translation is basically just moving an object. We're moving it up, down, left, right, some sort of combination of that. Now, we notice with this blue and this red triangle here, okay, that the triangle itself, the A is kind of up here, the C is over here on the left, the B is on the bottom right. As I move this triangle from here to here, those relationships all stay the same. A is going to be up there, B stays down here, and C is going to be right there as well. The other thing we notice, guys, too, is the blue triangle right here is my pre-image. That's my original. The red triangle is going to be my image, and I know this because you see these apostrophes next to the letters. That's what I was talking about, what's called prime notation. And so what we do is we actually don't call this A, we call this A prime. This is B prime, and this is C prime. And the reason why we do this is to kind of show that, A prime came from this point, A. B prime came from B, and then C prime came from C. Now, when we do a translation, we kind of look at it's a vertical and horizontal shift. So this particular one, I went 4 units to the left right there. So that's a horizontal shift of -4. I went 5 units up. So that's a vertical shift of +5. All right. So again, a translation is also called a slide. Sometimes is what you hear this called. So we're just moving it to a new location. This one went to the left and up, and went from this figure right here to this figure right there. All right, the second one we have, this is called a rotation. All right, and a rotation is sometimes also called a turn. And again, a rotation just sounds exactly what you think it is. We're taking the shape and we're gonna turn it, right? So if I have this shape right here, is what I start with. That's my pre-image. Okay, we're gonna take this shape and I'm going to rotate it, like this. Except for when we rotate stuff, we rotate it about what we call a point of rotation. And so in this case, it ends up being that origin right there. So this actually kind of ends up looking maybe a little bit more kind of like, so if I have kind of got outline my triangle right here, right? And I kind of rotate this. What you're going to see is it kind of rotates like so. Okay, around a point of rotation. So again, we'll get into every single one of these more in detail as we go throughout the unit. But again, right now we're just working on identifying the different types of transformation. So rotation, again, we're kind of spinning it. We're turning a shape. All right. Next one is what's called a reflection. And a reflection, again, is, it's exactly what you think it is. We have a triangle. In this case, I've got, we call this one my pre-image. And I've got a line of reflection. So this line of reflection, which goes right down here, right down the middle, it's on my y-axis in this case, and we just completely flip this triangle over that line of reflection, just like you would look in your reflection in the mirror, and everything looks a little bit backwards, all right? So the same idea with the reflection. We just kind of flip it over this line. All right, my final transformation, this is called a dilation, all right? And a dilation is when I shrink or enlarge a shape. All right. If you've ever been to the eye doctor, sometimes they put those drops in your eyes, and they, then they dilate your pupils to make them bigger so you can see inside them, and so they can see if there's anything going on in there. All right. That's what a dilation is. Dilation is the act of taking a shape and making it bigger and making it smaller. Okay. So we can see here in this example, this red triangle down here with A, B, and C. That's my pre-image. Now look at the blue triangle right there, A prime, B prime, and C prime. Obviously the second triangle is much bigger than the first one. So this is a dilation. But we notice that the shape, the red shape and the blue shape, the shape is exactly the same. The triangle looks exactly the same. It's just the second one's a little bit bigger than the first one. All right. And that's what's going to happen with the dilation. And again, with the dilation, we can get bigger like we did here, or we could actually get smaller with the dilation. There's not really a set rule. It doesn't have to go one way or the other. It could be really either or. All right. So again, the purpose of today is just to kind of introduce these types of transformations and kind of have an idea what to look for when we're doing these notes. All right. All right. So again, as I mentioned, guys, with transformations, with the first three that I talked about up here, with translations, rotations, and reflections, these are all called isometries or congruence transformations, meaning that the image and the pre-image are going to be congruent. So example number one here is just reviewing our congruent figures and identifying those corresponding parts. So what I want you guys to do here, go ahead and pause the video, try this on your own. I want you to identify all pairs of congruent angles, all pairs of congruent sides, and then I want you to write that congruency statement. So go ahead and pause the video and see if we can figure this one out. All right, so let's start with sides, all right? So sides, we got PR is congruent to KL, all right? Those both have one tick mark on them. We can go next up. I got PQ is going to be congruent to JL. And then lastly, I've got QR is congruent to, and that's going to be JK. All right, as far as my angles are concerned, I got angle Q congruent to angle J. I've got angle R congruent to angle K, and then I've got angle P congruent to angle L. So these are all my corresponding parts here. I've gone ahead and done this. We want to go ahead and write a congruent statement. Again, you can call that first triangle whatever you want to. I'm going to call it PQR. All right, and then just make sure the second triangle matches up. All right, so I went PQR, so PQR, so I have to go LJK as far as my next one's concerned. Triangle LJK, again, because P and L match up, Q and J match up, and then R and K match up as well. All right, so what I want you guys to do here is on your own, kind of go through and just identify, work on some of these you try out problems on your own. Number one is very similar to one we just did. And then 2 and 3 is just kind of asking you, like, what type of transformation do you think this is going to be? And then the last one is, do you think this is an example of a rigid motion? Again, remember that a rigid motion is also called a congruence transformation. So if you think this could have been a congruence transformation, tell me so, and then tell me why. All right, so that's going to be it for today. Quick video, and go ahead and try these U-turn outs on your own, and we will talk about them in class. Have a good day.